Hello, this is our presentation for Lab 5 Hardness. For this lab, we were measuring the hardness of different materials before and after heat treating it. To heat treat an item, or a material really, you need to heat it up to a temperature and cool it down, and rapidly cool it down really. This is done to enhance and strengthen the material properties like hardness.
A little bit about the theory of the crystalline structure inside the steel. The first process is the austenitization, which steel gets heated up very quickly, and the structure starts from a body centrifuge to a phase centrifuge. The next phase would be the quenching, where it gets rapidly cooled, and then the carbon atoms are locked inside the phase centrifuge, causing the material to become harder and more brittle than it once was.
To measure hardness, there are multiple different methods. For this lab, we did the Rockwell test, which involves pressing down on the material with an indenter and measuring the value depending on the settings that it had. For when heat treating the items, or material really, and there are multiple methods. We used 3 different methods to cool down the material. One with water, one with oil, and one with air. Okay. Another method is the Bernal test, which we tested aluminum on. This test involves a 10mm diameter indenter, and for this we use the equation shown in figure 2, which involves plugging in the force as P, the diameter of the indenter, which is D, and the lowercase d is the diameter of the indent on the material.
This is our results for our Rockwell hardness B testing, and we found that aluminum was the softest material, and the hardest material was the water quenched 1045. For our results for testing our Rockwell C hardness, our hardest material was again the 1045 water quenched, and the softest now was the 1045 air quenched, because we did not test the aluminum because it was going to be too soft to get a measured value. When we used our Bernal hardness testing, we had to use a pneumatic machine, and we were given a 500 kilogram load on it, which would then give us our experimental value of 75, and because our theoretical was it being a 6061 T6 aluminum, it should be 95, so it gave us a percent error of 20%.
Heat treating does not always increase the hardness value of a material. Quenching incandescent 1045 steel, oil and water significantly boosted the tested hardness value. Quenching is an effective technique for increasing the hardness of metals, and the increase in hardness is only dependent on the speed of cooling, not the quenching medium. To conclude, the process for testing hardness sample was experimented with during this lab. Quenching is an effective technique for increasing the hardness of metal. The increase in hardness is only dependent on how quickly it is quenched. And in general, the harder the material, the higher the tensile strength, but there are some exceptions like composites or ceramics. In the future, we would like to test quenching, cooling it even quicker to model the ratio of time versus cooling. Test quenching with even cooler quenching mediums such as ice water or liquid nitrogen, and like to test quenching with different starting temperatures of the metal. Here are the references used during the lab.